I am Nicolas Tejos, and I'm giving you a summary of this paper that we published last year as part of the ARC-TOMO collaboration. The paper is about telltale signs of metal recycling in the circumgalactic medium of a redshift 0.77 galaxy. The targeted galaxies illustrated by this image is the one in the center, which we call G1. It's surrounded by gravitational arcs that are bright enough for us to perform gravitational arc tomography, looking at the magnesium 2 absorption in the circumgalactic medium of this intervening galaxy. The data set is composed by HST imaging, VLT-MUSE, and Magellan-MAGE spectroscopy. We start with the image plane, in which we beamed the MUSE data to match the seeing, so all of these positions are mostly independent. 42 positions around G1 are allowed by the data to prove whether there is magnesium 2 or not. Because of the lensing, we need to reconstruct the geometry at the observer plane, which is illustrated by this inset. And in the observer plane, the geometry looks like this. The arcs are around G1 as illustrated in the image. G1 also shows some kind of morphological interesting features like spiral arms when looking at that in detail. From the MUSE dataset with the unbeamed data, we can provide a map of O2 emission, which is strong enough to do a morphokinematical analysis. And the morphokinematical analysis allows us to fit a rotating disk to the O2 emission, which is it's good because then we can extend the model to much larger distances to cover the circumgalactic medium and see if the magnesium 2 absorption is consistent or not with the O2 kinematics. Here is one of the interesting maps. This is one of the first maps in which we see magnesium 2 absorption all around G1, not in all of the spaxels that we look for. Some of them are upper limits, looking at the blue arrows, blue triangles in this map. But we also look at the kinematics, which are illustrated in the bottom panel here. And we see that the arc north is mostly blue shifted, the arc south is mostly red shifted. We compare the kinematical model from O2 extended to the circumgalactic medium and see if this blue shifted in the north and red shifted in the south could be explained by the rotation, and the answer is yes, it can be explained by rotation for most of the spaxels, but not all of them. Some of the spaxels are inconsistent kinematically with this extended rotation, which are marked by the crosses. So we believe we are also seeing signatures of outflows. Indeed, looking at the geometry, one will expect to having a blue shifted outflow in the north and red shifted outflow in the south. And when we look at the high resolution data from MAGE, we indeed see two components. First, down the barrel to G1, a broad component in magnesium 2. And then we look at the arc north, which has enough CO2 nodes for doing this experiment. We see indeed two components. One component that is consistent with the extended rotating disk, but another bluer component that is inconsistent with the rotating disk, which we believe it's evidence of an outflow that reaches that part of the circumgalactic medium. So to summarize, we are witnessing signatures of a galactic outflow and extended rotating disk in the circumgalactic medium of a redshift, high redshift galaxy. Please see the paper for more details, and thank you for your attention.